Okay, we've got to solve this here equation, and we've got cos of an addition, so I need to apply the addition formula for that from your formula book. So I need to do cos of x times sine of 45 degrees minus sine of x cos of 45 degrees, and that's got to equal root 2 sine x. But sine of 45 degrees is 1 over root 2, or as your calculator will tell you, that's equivalent to root 2 over 2, minus sine x cos 45 degrees. Cos 45 degrees is the same thing, actually. So sine x times root 2 over 2, and that all equals root 2 sine x. Okay, so I've got some terms in sine x, which I can combine, and a term in cos x. So let's get all the sine x's on this side. So, well, you know what? I could divide this equation through by root 2, and I could multiply it through by 2, in fact. So if I do that, then this just becomes cos x. Okay, this one will become 2 sine x, but I'm adding this. This will become minus sine x. So I'm going to get cos x equals 3 sine x if I do all of that properly. So how do I solve this? I've got cos x's and I've got sine x's. I'd just like to have one trig function. Well, if you remember, the trick is to divide through by cos x. So this will be cos x over cos x is just 1. And when I divide this by cos x, the idea is that sine x over cos x is tan x. So 3 tan x equals 1. In other words, tan x equals 1/3. Now, that's not got nice solutions. We have to use the first x, second x method on our calculator. So we do inverse tan of 1/3, which my calculator claims, oh, I've got to say show my method. Okay, must show a method, otherwise you could be just cheating from a graphics calculator. My calculator claims this is 18.435, and the second x we always do for a tan 180 degrees plus the first x, okay, which in this case is going to give us 198.435. Okay, and then we need to get any 360 degree repeats that are in this interval. Well, this first solution is okay as it is. This second one, I'm going to need to take away 360 degrees from it to get it into the interval, and that's going to be my lot. Now, it doesn't give an accuracy in the question, so in degrees, it's normal to give them to the nearest 1 decimal place. Always initially find more significant figures than you need and only round at the end. So our x values in the required interval are 18.4 degrees, and this one, take away 360 degrees, is going to be minus 161.6 degrees. And we need a comma between those, and we need to double underline them.